All right, I'm Specialist Jeffrey Anami. I'm from the 1895th Head and Neck out of Fresno, currently attached to the 352nd cast for this exercise. The piece of equipment right over here is a centrifuge. Serial centrifuge is usually used in blood bank. It may be used in chemistry, but it's usually the secondary centrifuge. So after a hard spin done in a larger centrifuge, we come to the serial centrifuge. And then we use it to test ABRH on a patient. So if you don't know what ABRH is, it's your blood type and your rhesus factor, which is the pos or negative. And for the quick spin is 15 seconds. That's when we're actually using antibodies from your serum out of your blood and antigens off your RBCs or your red blood cells for testing to see if they agglutinate or not. And if it's a positive agglutination on the anti-sera on your antigens for RBCs, that'll tell you what your blood type is. Or for plasma, they have an apheresis machine, similar to the machine that is used for people that have sickle cell anemia. So basically, it could be either a 2-stick or a 1-stick. So that example, a 1-stick is they only use one arm, puncture you in, and they draw the blood out. It goes through the apheresis machine, which we don't have here, I can't show you. It spins, it pulls out blood, and there'll be a saline bag for replacement for your plasma. So as you're doing your platelets and your plasma, it'll replace what they take out so you don't become, your hematocrit doesn't get too high so that your blood pressure will stay normal. And then it will return it down that same line in the process. Now the 2-step is the draw line will be in one arm and the return arm will be in the other arm. So that's the 2-stick method. Most places go to the 1-stick because the majority of donors don't have two good veins on both arms. So they usually go to the one, and it's a process that takes anywhere between half an hour to 45 minutes for a healthy soldier or donor. All right, this is our Vortex 2 Genie. It is basically our machine to make sure that when we're working with blood specimens and or serology specimens, that they're, when the testing requires for a homogeneous solution, that it's homogeneous. So all you have to do is press down. Usually we'll have a cap on it, so in case we've overfilled the test tube, it won't spill out. And all you have to do on touch is push it down and it'll rotate. Lift up, it'll stop. And then you can have it on the on position, constantly rotating. And do this. This is our digital dry bath incubator. It is technically used for blood banking, which this ISO does not have, but the digital dry bath is here. It is usually used for incubating when you're doing antibody screens for your panels. So if you're a female who's been pregnant, has a baby, and the doctors always order a type and screen on you, and before you have childbirth or a C-section, just in case something goes wrong, you have the blood. And so we're making sure for this, we're doing the antibody screen, there's an incubation period, because you may have what is called a warm antibody, and so the antibody is only active at body temperature. Antibody screens made up of other people's cells that have antigens, and then your serum, which will hold your antibodies in it, are in the cell incubating. And once the incubation is complete, we'll put them, actually this is one of them, we can either put on a vortexer or hand shake it, and then put them into this centrifuge again for 15 seconds, spin it down, and then read it. And if it's agglutinated, then you have an antibody. So usually downrange, we won't be doing antibody screens because the time involved in identifying the antibody usually would mean that the patient would already be dead by the time you identified it, because it takes a good 2 to 3 hours to identify an antibody. So this is also used for certain urinalysis. So downrange, if we have a urinalysis and somebody's coming up positive of something in your urine on one of our rapid urine tests, we'll portion off some of the urine into a test tube, warm it up to back to body temperature again, because at room temp it's 70 degrees, body temp is 97. Warm it back up and then rerun the test, and if it comes up negative, then we know it was just the fact that they had proteins in their urine that was causing the false positive, because it was at room temp versus body temp. All right, this is the vacutainer. This is usually what you would draw your blood in, but right now for instructional purposes, this is about the same size of the test tube that would fit in here, as you can see. So if you, right now, since this is actually a general lab but not a blood lab, we're going to be using this probably to warm up the patient's urine back to body temperature instead of room temp, to dissolve any proteins or that react at cold versus body temp. So we would put it in, wait per SOP probably 5 to 10 minutes. Whatever may be interfering, usually a protein, causing the test to come up falsely positive. Once we warm it up, we would go back to whatever the test kit is, run the test again, and if it came up negative, we knew it would be a reactive protein at cold temperature versus body temp, so that we can also annotate that and let the doctors know that they have a cold reacting protein to the test, and that could also help the doctor identify what their prognosis is if the rest of the lab here was missing. So if they know their old-timer stuff, they can do it. And so once you're done, you just take it out. Again, go back to the vortex, spin it, because I turned it off, but turn it on, spin it up. And if we had it like a strip, I'd be wearing gloves, of course. Pop the top, put it in the strip or test, pull it back out, get whatever screen that I'm supposed to use, go up against to read it, and if it came up negative, then we know they had a cold reacting protein and they need to have their blood warmed, or not blood, urine warmed before testing is done, to make sure they keep it from getting a false positive on the testing. So this is the iStat. It is considered a POCT, or point of care testing equipment. We have it here in the lab to run our blood gases and basic chemistries. There's another version of this that actually has a printer attached. Off to the side over here, we have the printer as a separate piece. The cartridges are loaded into here, and on the cartridges, which you have a picture right here, which is actually about the right size, you put the blood in right here, either via syringe or transfer pipette, close it, stick it in, and you hit this little button called 2 for iStat cartridge, and then either you scan it off another one, there's be a barcode, scan the barcode off the package, and then you would run the test.